you have different tasks. We can see the PPT for the task. Okay, we have three types of tasks. One is task control. When code runs, should use task to run code only when the necessary. Continuous task. The continuous task runs in free time. This task is run in free time, and then watchdog for that task is the 500 millisecond is the by default. You can change that watchdog also, and if you want to change the continuous task, and also you can change the with the another task. Then periodic task, you can change that continuous to periodic. You can create a periodic task, but here the periodic task you can select your how much period you want to give for the execution is 10 millisecond, 20, 30 or 100 or 1000 millisecond. It depends on the programming execution or the priority. It depends on the priority. Lower number of else higher priority. If you given the lower number here, then priority of that task is very high, and if you giving the higher number, then priority is lower if the higher number is there. And watchdog you can keep as it is 500 millisecond. If the cycle scan is going more than the 500 millisecond, then your CPU goes in fault mode. If the execution time is more than the 500 millisecond, if you have some delay in the program, or your program is heavy, then you can change this watchdog timer as a 1000 millisecond or 700 millisecond, whatever, depends on your execution required in the program. If you have some for loops, indexing or SFC program, that time you need to change this watchdog timer into the higher side. Otherwise this 500 millisecond is sufficient, because in the priority you are in the periodic cycle you have set as a if you have set as a 2000 millisecond, means after 2 millisecond one cycle is executed, and your watchdog timer is 500 millisecond, then no problem, because uh, you have given 2000 millisecond as a periodic task execution, but it will execute within a 10 second. That's why the watchdog timer it will work. But if the cycle time is 2 second, 2000 millisecond, but and your execution time for that particular task it will take 3000 millisecond or more than 500 millisecond, then that time your CPU goes in fault mode. For to avoid that, should not add uh, open-ended for loops, which is it doesn't have any end, and it will the cursor will continuously running in same loop, again start again uh, stuck in the loop. Then that time you will face this watchdog failure time, and then your CPU will go into the fault mode. Okay, then periodic priority, and here the event task. This event task is based on the event trigger. Whatever event you have triggered, suppose fire and safety is there. Suppose you have oil and gas plant, and you are using the fire and safety. The this event task have higher priority than the other task. If the fire is there, and then fire sensor detects the fire, and it will trigger this task, and your safety logic is started executing, and your safety actions will take by this event task. That time you can use this event task. Most of the time when the safety is required, that time you can use this event task. Event task you can use 32 event tasks and 32 periodic tasks, uh, or uh, in the all tasks you can use only one continuous task. This periodic task is you can use if you using the one continuous task and you using 31 periodic tasks, then it will work. But if you want to extend it more, then that is not possible, because there is limit continuous tasks plus event or periodic task. There is maximum limit for this task is 32 tasks. And then okay, then in the task under there is a line program. You can add thousands of line program under the task. Means you can multiply 32 task into 1000 of the programs, and under the program you can add thousands of routines. You can add there is no limit for the routines and this program. You can add multiples, but there is some limitation, depends on the memory sizing of the controller. If you have 2 MB controller and your program is going more than 2 MB, then it is not possible because of the limitation of memory sizes. Then program holds in routine. Okay. You can arrange your program like this manner. Is the program can be used to modularize code parts of the machine, process and system. You can divide your program in machine, process, system, and you can add those program under the task. Suppose you have task 1. Under the task 1 you can add initialize, add materials, then different phases you can add under that task. Means that program is different, and under that you have your logic is there in the routines. You can organize as per your requirement. Then routines, in the routines can be used to further modularize code for sub parts of the machines.